vertical asymptote. Great job. What about the limit as x approaches 6 from either side?
Does not exist.
Does not exist. Very good. And what do you say about x equals 6? Vertical asymptote. What about when x approaches negative 7 from either side?
Negative infinity.
Correct. It does not exist, but I have to write negative infinity. And then x equals negative 7 is a vertical asymptote. Okay. The next, before we move on to other examples and we talk about more limits and more ideas behind limits, I would like us to graph a piecewise defined function again, piecewise defined function. We had that on the skills assessment, but you just check the graph, and that's not what I'm interested in. And then I would like us to choose, and I'm going to write this down, to choose to sketch a graph given information about the graph. So the book has, we can make up. We don't have to use any of these problems, but I would like to show another piecewise defined function. You want to choose any of these two, or you want me to invent another problem? Which one?
You could just use one of those.
Okay, you prefer the one with the natural log and exponential? That looks interesting. Okay, let's do 11. So this is my page 4. So this is 11 on page, yeah, there is no page number. So this is in 2.2. And we have f of x. And we have e to the x for x less than or equal to 0. We have x minus 1 for x between 0 and 1. And we have natural log x for x greater than or equal to 1. Okay, so my question is, we have several questions here that I would like to add on. I don't care for what they say, but let's read it. Sketch the graph of the function and use it to determine the value set of a for which the limit does not exist. The limit exists. So we're going to look at where it doesn't exist, and then we'll take it from there. But so when we're asked to graph a function, what is our first concern? The very first thing we need to do, absolute first thing before we do anything.
The intercept?
Further before that. It's the absolute first step for any graph or any function.
Domain restrictions?
Close, yes. How do we call that?
Domain.
Thank you. Yes, that is our first concern. I cannot plug in numbers if I don't know what numbers I can plug. So yes, the idea is sort of the restrictions, correct. So that I completely agree with. But in this case, I'm looking at this interval, and I see it's this. Obviously. Either say x less than or equal to 0, or I say this, it's the same thing. This one is basically 0, 1. If one or the other, they mean the same. And this one has 1 to infinity. And from here, I can easily determine the domain. I could have determined the domain from here, but you know why I need those symbols. So what do I conclude then? What is the domain of this function?
All real numbers.
Great, great job. Thank you very much. Nothing is missing. I have everything to the left of 0. I have 0. I have between 0 and 1. I have 1. I have 1 to infinity. Nothing is missing. So that's what I'm going to put in the table. And definitely these values of x have to be in the table. They are crucial values because the function changes at 0 from this to this, and at 1 from this to this. So these must be very important x values. I will copy now the symbols I see under 0. A bracket to the left and a parenthesis to the right, and they are touching each other. And the same thing, 1 parenthesis to the left and a bracket to the right, they are exactly under 1, not like this. Okay? So they're exactly, the symbols are immediately under 1 and immediately under 0. I know you're going to say that this is an overkill, but functions are not always presented in the correct and nice order. To the left of 0, I will be using this. Between 0 and 1, I will be using this. And to the right-hand side of 1, I will be using that function. So for e to the x, I'm going to plug in -1. It's an ugly number. It's 1 over e. I have no idea what that means. 1 divided by roughly 3. Ugly number to plot, but it is what it is. When I plug in 0, I get 1, and 1 is placed inside the bracket. In the middle now, when I plug in 0, you should be appalled and say, no, you cannot plug in 0. And I'll say, fine, bear with me. I will plug in 0, place it inside the parenthesis, and I will not forget that this is an open point. This will be a full point because of the bracket, but this will be an open point because of the parenthesis. Then I'm going to plug in 1. Again, you should say, no, no, you can't do that. And I'll say, please bear with me. 1 minus 1 is 0. And I will keep in mind that if this number turns out to be something else, this will be an open point, and this will be a full point. But when I plug in 1, I do get 0. So this will be a full point then, because these two values are the same. When I plug in 2, I get a natural log 2. I have no idea what that is. I'll approximate it in a minute. So at this point, if you ask me what x values, which of x values the function doesn't have a limit, I know exactly it's the only one is 0. Because the limit from e to the x, when x approaches 0 from the left, is 1. And the limit of x minus 1 from when x approaches 0 from the right is -1. They're right here. Here the limit exists because the left-hand side approaches 0, the right-hand side approaches 0. There is no discussion there. And therefore, the either side from this function, I cannot put either one. I have to write f of x, is dne. So without even graphing, the table tells me everything I need to know. I see that the function here has a limit from either side of 1 because the numbers are the same. Here from either side of 0, they're not. The limit exists everywhere else except at 0. So this function, when we graph it, we'll see it has a limit everywhere except at 0. That's one reason why I recommend this table. You can invent your own table, it's up to you. So now let's graph. I will graph 3 different colors only because I want you to understand that the 3 branches cannot overlap. So I'm using, I love my colors as you see, but that's not the issue. What I'm saying is I will graph them in 3 different colors, although it's only one function, just to signify that they do not ever overlap. So when x is 0, y is 1. I'm not going to mess with that value because I know how to graph e to the x. I don't care for -1, 1 over e. In the middle, I have a linear function, so this was exponential, this is linear. So at -1 with an open point, and at 1 with a full point. Why full point? Because the values are the same. And now I continue with a different color on the other side. And I have to graph the same point. And I know how to graph natural log. I don't care about 2 comma natural log 2 because we know how to graph it. And as we see, this function, f of x, has a limit everywhere except at 0. Also, I'm going to ask you from the graph, I would like you to identify for me the range of this function. You can also easily determine it from the y values here and from the graph. And then we'll
The range would be 1, so bracket 1, -1, parenthesis. Right?
so let me refresh your memory on how we determine the range. We imagine that we draw horizontal lines, and when my horizontal lines start hitting the function, that's where I start with the range. Ready? No, no, no. Close. Close, but not quite. Yes, 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 yes. So what is the range of this function?
Negative parentheses and -1 to infinity.
Well done. Is this clear? Yes?
Yes.
Perfect.
Yeah.
Excellent. Moving on, I would like to look at one example before we start looking at our quiz. More than one example. Few. And feel free to, I forgot to mention that in a traditional class when I'm in front of my students and we have books and stuff, which is fine now, please feel free to choose any problem. So we'll see problems 23 through blah, 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 and feel free to choose. I'll be more than happy to work on a problem that you want to choose. So I'm on page 5. Okay. So we are given some conditions. Problem 15, 16, 17, 18. We're given a bunch of stuff. And we're asked to sketch the graph of an example. In other words, I can come up with one, you can come up with one, everyone can come up with one, and they will never be the same maybe. Of a function, example of a function that satisfies all the given conditions. The reason I like this type of problem is that it really solidifies what we are talking about here. Are we done with this? Can I move on? Okay. So any preference? 15, 16, 17.
Lucky number 17.
Excellent. I completely agree. 17 is a lucky number. Okay, 17 then. So we have limit of f of x equals 0 as x approaches -1 from the left. Then we are told limit as x approaches -1 from the right of f of x is 1. Then they're telling us limit of f of x equals 3 when x approaches 2 from either side. Then they're telling us f of -1 is 2, and finally f of 2 is 1. Let me put this aside. At this point, this is a bunch of gibberish to me. Anyway, if you can envision this, go for it. But I also have to explain what I'm doing, so I'm not going to look at this before I make sense of it. If I can make sense of it, I will not be able to get it done. Okay. I organize everything in my table. X could be anything from -infinity to infinity. Step by step, I'll put them in. So let's say I start with f of 2 equals 1. That's no problem. This is done. Then I see f of negative 1 is 2. This is done. Then I see the limit from the left of negative 1. The limit from the left of negative 1 is 0. Parenthesis. We know why. This is done. You don't have to cross them out like that. I'm just making sure I put everything in. The limit of f of x as x approaches negative 1 from the right. Very clear. Parenthesis inside 1. Done. And finally it says the limit of f of x as x approaches 2 from either side is 3. Fine. Parenthesis. Parenthesis. I cannot put bracket. If I know that 2, when x is 2, y is 1, I cannot use brackets here, obviously. The function will not be a function if for x equals 2 is 1 and also for x equals 2 is 3. So that's why it's very clear that these must be parentheses, not brackets. Okay, now I see what I have to do. I organized my gibberish, and I'm going to start with negative 1 comma 2. Of course, I'm going to continue with 2 comma 1. And now it says, on the left of negative 1, the function approaches 0. Okay, fine. You choose whatever you want. You can come from here, you can come from here, you can do whatever you want. On the other side of negative 1, the function approaches 1. Okay, fine. I haven't connected it yet. At 2, on the left and right, approaches 3. 1, 2, 3. That's my graph. I check again and make sure that I have all the information in there. 2 comma 1, yes. Negative 1 comma 2, yes. Approaching 0, yes. Approaching 1, yes. Approaching 3 from either side, yes. And that's my graph. You can do whatever. You can go up, you can go down, you can do this. You can put a vertical asymptote if you want here. Going up and then going down. You can be as creative as you want. We are only asked for an example. Any questions?
No.
Moving on.